Hello everyone, welcome to Young Innovators. In our previous video, we had learned about sensors and worked with one of the sensor that is available on Tinkercad. Hope all of you enjoyed the video and tried the circuit that we built. Now, let's move on to our next topic that we all are familiar with and have known about this term from long, a motor. We all know what a motor is. We have been using it and we have seen it in many appliances that we frequently use at our places. May it be in a fan or a mixer grinder. You all have observed that the spinning movement of a motor tells us if the motor is working or not. So, in simple words, we can define a motor to be an electronic component that converts electrical energy to mechanical motion. If we take an example of a fan, the fan is rotating when the switch is on. So here, we are converting the electrical energy to a mechanical motion or a rotatory motion of the blades in the fan. This job is done by a motor. Due to its simple and easy working, you can find them in everything from electric trains to remote controlled cars. How many electric motors are there in the room with you right now? There are probably two in your computer, one spinning in your hard drive and other powering the cooling fan. If you are sitting in a bedroom, you will find motors and hair dryers and many toys. In the bathroom, there are extractor fans and electric shavers. In the kitchen, motors are in just about every appliances from washing machine to microwaves. Electric motors have proved themselves to be among the greatest invention of all time. I am sure you guys are now excited to know how these motors work. To understand how electric motors work, the key is to understand how electromagnets work. An electromagnet is the basis of an electric motor. An electromagnet is made of coils of wires with electricity passing through them. Moving charges create magnetic field. So, when the coil of wire have an electric current passing through them, the coil behaves like a magnet. Suppose we bend our wire into a square, U-shaped loop. So there are effectively two parallel wires running through the magnetic field. One of them takes the electric current away from us through the wire and the other one brings the current back to us again. When we switch on the electricity, one of the wire will move upward and the other wire will move downward. If the coil of wire would carry on moving like this, it would rotate continuously and we would be well on the way to make an electric motor. But this can't happen with our present setup. The wires will quickly tangle up. Once the coil reaches the vertical position, it would flip over. So the electric current would be flowing through it in the opposite way. Now the forces on each side of the coil would reverse. Instead of rotating continuously in the same direction, it would move back in the direction it just had come. Imagine an electric train with a motor like this. It would keep shuffling back and forward on the spot without ever actually going anywhere. One way to overcome this problem is to use a kind of electric current that periodically reverses its direction, which is known as an alternating current. But if we use this current, the devices which need slow current will get damaged. So we go with another option to overcome this problem, which we will learn further. Next, let us look at types of motor. There are two types of motors, AC motor and DC motor. An AC motor is a motor that is driven by alternating current. The AC motor commonly consists of two basic parts: an outside stator having coils supplied with alternating current to produce a rotating magnetic field, and an inside rotor attached to the output shaft, producing a second rotating magnetic field. Applications: AC motors are used in electrical appliances like refrigerators, fans, washing machines, hair dryers, mixers, etc. AC motors are further classified as asynchronous and synchronous motors. Synchronous motors are the one that converts AC electrical power into mechanical power and is operated at synchronous speed. Asynchronous motors are the machines which converts AC electrical power into mechanical power by using the electromagnetic induction phenomena. Now coming to DC motors. DC motor is a motor that is driven by direct current. Small DC motors are used in tools, toys, and appliances. DC motors are again classified into two types: brushed motor and a brushless motor. Brushed motor is the one that generates motion directly from DC power supplied to the motor by using internal commutation, stationary magnets, and rotating electromagnets. Brushless motors use one or more permanent magnet in the rotor and electromagnets on the motor housing for the stator. You can see a DC motor on your screens now. If you see carefully, you can see many windings and paths on the motor. Let's see what are they. Stator. Every electric motor has two essential parts. One stationary and one that rotates. The stationary part is the stator. Though configurations vary, the stator consists of permanent magnet. Rotor. Inserted into the stator is the rotor, usually consisting of copper wire coiled around the axle. When current is applied to the coil, the resulting magnetic field interacts with the created magnetic field by the motor, and the axle begins to spin. Commutator. An electric motor has another important component, the commutator, which sits at the end of the coil. It is a metal ring divided into two halves. It reverses the electrical current in the coil each time the coil rotates half of a turn. The commutator periodically reverses the current between the rotor and the external circuit or the battery. Axle, which gives supports for the rotor. When external wire comes in contact with the brushes, rotor will start rotating, which in turn rotates the axle. Brushes and contacts. When external wire comes in contact with brushes, rotor part will start rotating. One end of the coil is attached to the each half of the commutator. The electric current from the battery connects to the motor electric terminals. These feed electric power into the commutator through a pair of loose connections called brushes, made either from piece of graphite or a thin length of springy metal, which brush against the commutator. With the commutator in place, the electricity flows through the circuit. The coil will rotate continuously in the same direction. So, in this way, the coil completes the one rotation in a single direction when given power to the leads, making the motor spin continuously. Motors are widely used in all the applications which we see around us, but we have to take care of what kind of motors are best suited for the application and what is the maximum power that we need to give so that neither the product nor the motor gets damaged. Hope all enjoyed the video. For any queries, do comment in the comment section below. Thank you for watching.